In the first part of the training series, we are going to talk about the basics of using SimLab VR Studio. Once you open up the application, the welcome dialog will appear, where you have a few options to go from. The first tab in the bottom will display the recent files that you have used, where you can double-click a file and it would open. The second tab would be the Help tab, where you can select the first item and it would walk you through a quick tutorial on creating a basic interactive VR experience. The second item would be the Academy, which is also accessible from the library panel at the bottom of the screen, in which you will find a huge collection of video tutorials along with the needed assets to learn SimLab VR Studio, starting with the basics and all the way to advanced training and techniques. And the last item would be the Help, which would open the online documentation where you will find elaborate explanation of each tool and function in SimLab VR Studio. Next is the License tab, where you can view which license you are using as well as the ability to activate a license by clicking Register. The next tab is the News tab, where it would contain news and announcement by SimLab Soft, and lastly, the About tab, where you will be able to update the version of software you are using once a newer version is released. In the top section of the window, you will have the Open Environment, Open Scene, and the Create Empty Scene options. The Open Environment option would grant you access to a collection of free-to-use environments in the first tab, which you can use as the base for your VR experience. In the second tab, you will find 3D examples, which are environments that also contain ready-to-use VR experiences which you can also run, explore, or learn from. Click on the white arrow to the left to go back to the main page of the window, and click Open Scene. Select the file named environment.zim, which is provided with the training material, and click Open. This is an interior environment with a platform in the middle, where you will find a table and a control panel, which is suitable to use for product demonstrations, and that is exactly what we need for this training. Before we start, let us talk about the basic controls in SimLab VR Studio. If you were to hold left-click and move the mouse while it's in the 3D area, you will rotate the view around the center, so by moving the mouse left and right while left-click is being held, you will rotate horizontally, and if you were to move the mouse up and down, you will rotate the view vertically. Holding the middle mouse button or the mouse wheel and move the mouse would pan the view. Similar to rotation, moving the mouse sideways would pan the view horizontally, while moving the mouse up and down would pan the view vertically. You can also use the arrows on the keyboard to navigate the 3D area by mimicking the walking movement of a character. You can combine holding left-click and walking at the same time to have a precise navigation of the scene. To select an object in the 3D area, simply point the cursor at it and use left-click. You can then press Ctrl and J, or click the Zoom to Object button from the bottom bench to zoom in on the selected object. Zooming in on an object focuses the view on the selected object and also makes it the center of the view rotation, so now when you hold left-click and rotate the view, you will notice that the camera is rotating around the objects you have zoomed in on. In the panel to the left, you will find the object tree, where all elements in the scene will be displayed, and the selected object will be highlighted. From the objects tree, you can select different objects or parents by simply left-clicking their name in the tree. Next to the selected object in the 3D area, you will find the Quick Access menu, from which you can access the most essential tools for objects control. The up and down arrow will go up one level in the assembly. For example, if you were to select the Cylinder 26 assembly and click the up arrow, the selection would change to the Stick assembly, which is the parent for that assembly, and if you were to click one more time on the up arrow, the selection would move to the Panel assembly, which is the parent of the Stick assembly. Clicking the down arrow will go down in the hierarchy one level. Select the panel assembly, then click the first icon from the left in the Quick Access menu to open the transformation controls. The transformation control will appear at the center of the object or its pivot point, and it's comprised of 3 arrows, 3 planes, 3 quarter circles, and a sphere in the middle. If you were to left-click and hold the red arrow and move the mouse, the object will move along the arrow's direction in a single axis. Same goes for the blue and green arrows. Keep in mind that these 3 arrows are not always necessarily perpendicular to the object, since the pivot point might be rotated, which we will get more into further in. If you were to click and hold the cursor while pointing at one of the 3 planes, the object would move in the same plane as the selected plane and along 2 axes. You can press Ctrl and Z on the keyboard to undo the last action you have taken, and in this case, the planar transformation. Click and hold the circular transformer located between any 2 arrows to rotate the object around the axis of the 3rd arrow. You might have noticed that there is a numerical value that changes while you are transforming the object. In this case, it's displaying the angle since we are using the rotation tool. You can click on the text field and type in the value if you want to rotate the object at a certain angle. This is of course also applicable to movement, where you can type in a value of how much the object should move. So if you were to move an object in a certain direction, then type 0.5 in the field and press enter on the keyboard, the object will move in that direction half a meter. The sphere at the center of the transform tool enables you to change the scale of the selected object uniformly. Similar to before, you can type in a number in the scale field to scale the object at a certain multiplier of its previous scale. So for example, if you were to type 2 in the scale field, the object's size would double. Typing in a value of 0.2 would scale down the object to 1/5 of its size. Let us now import the model, which we will create a presentation for in the training, but before we do, I am going to click the light icon in the bottom bench to disable the default headlight in the scene and only have the added lights in the scene be enabled, which would be more comfortable to work with. To import the model, go to the bench at the top and click the first item, which would open the file menu, then select Import. We are going to import the FBX file included with the training material to the scene. Notice that SimLab VR Studio is able to import a huge variety of 3D file formats along with the materials and textures while maintaining the integrity of the object's tree, making it fully compatible with all major CAD design applications. Select the toy car model and click Open. In the Import File dialog, you will have a few options. The up vector determines the upward direction of the imported model, so for example, if the CAD application you are using has the y-axis as the up vector, then set the up vector to y. For the toy car model, the up vector was z, so I'm going to leave it at z. The Place in View option would neglect the imported model's original position in the world and will place it in the view, which is suitable for importing props. But if you are importing a part of the environment model that you have been working on, or you are concerned with the object fitting in a place exactly as it was designed, then disable this object. The second option is to track imported file. If this option is enabled and you modified the imported model in a CAD design application and saved it over the existing file, SimLab VR Studio will update the model with the new file. The Zoom to Imported Model option will simply focus the camera and zoom it in on the imported model. Under the file-specific settings, you have the option to import rigid object animation, which is the simple form of animation where the object's transforms are animated, and the flex objects animation, which is the skeletal animation that uses joints and bones to animate a 3D model. For the toy car we are importing, you can leave these options on or off, since the model doesn't have any animation to begin with. I am just going to disable the Zoom to Imported Model option, and then click OK to import the model. As you can see, the model has been placed in the view, but it is not quite exactly where we want it, since we need it to be placed on top of the table. Now we can either use the Snap to Object tool, or we can manually use the arrows and planes in the Transformation tool to place it on the table. Press the Snap to Object tool or press the shortcut N on the keyboard, then click on top of the table to place the car model there. Now that the model's wheel are precisely above the tabletop, we are just going to use the Transformation tool to center it on the table. Feel free as well to rotate the car in whichever direction you see fit. Click on the wheel and open the Material tab in the Properties panel to the right. Notice that SimLab VR Studio assigns a material to each object based on the original material for the object in its native CAD application, but in some cases the CAD application doesn't have a suitable material for each object to begin with, therefore it might be a good idea to use SimLab VR Studio to modify the material on each object. If you were to click the material icon from the Quick Access menu, 4 sections would appear. The first one is plastic, the second is metal, then matte, and finally glass. These are the 4 most common materials in 3D scenes, and to convert the selected object's material to one of those, simply point the cursor to a type of those 4 materials and click it. For the wheel, I am going to select matte, then under matte I'm going to select rubber. Notice that the reflection color has changed to a darker tone, since rubber materials are barely reflective. Select the car's body and from the Material menu, select Shiny Plastic. Feel free to play around with different material for each component until you're happy with the appearance. Now that we have covered the basics of material changing, let's move to the environment and lighting. From the object tree to the left, select the first item named Environment, with the sun icon next to it. The first tab under Environment is the HDR tab. HDR images are high dynamic range spherical images that are used to emit light in the scene based on an image, and they affect the light as well as the surface's reflections in a VR experience. You can click the color box and change the HDR's tint by changing the color from white to any other color. You can also adjust the rotation of the HDR since it's a spherical image, as well as the brightness. If you were to click the browse icon next to the HDR thumbnail, more HDR images options would appear. These images, if not used previously, will have a yellow arrow, indicating that they are stored on SimLab Cloud and need to be downloaded. Select an HDR and from the dialog that appears, click Download. Sign in with your SimLab account, or click Sign up to create an account for free. Once the download is complete, click Use Item to apply the downloaded HDR to the scene. Notice that whenever you change an HDR image, the brightness value changes since this value is stored with the image, so do not forget to change it if you found it to be too bright or too dim in the VR experience. Switch to the second tab, which is the sun. From here you can enable and disable the sun and sky system. The sun and sky system, when enabled, will create a sky around the environment and emit a directional light mimicking the behavior of the sun. You can change the elevation and horizontal value of the sun to change its location in the sky, which directly affects the angle at which the sun rays enter the scene. You can also click the icon next to the slider to display the interactive sun transformation tool. From the Transformation tool, rotate the white arrow in the direction you want the sun rays to travel along, then click the check mark to confirm the direction. In this environment, since there's a uniformly designed sky portal at the top, I think the sun's position to be placed exactly at the top of the portal would have a nice effect, so I'm going to set the elevation angle to 90 degrees. Under lighting strength, you can change the value for the sky and the sun separately. Changing the sky's strength would affect the overall ambient light in the environment, while changing the sun's value would affect the direct rays of the sun that are going in the direction we have specified earlier. A final note on the sun and sky is that they can work together with an HDR image and they do not necessarily have to be exclusive. Moving to the third tab, the background image affects the backdrop of the scene. When set to from environment, a sky will be displayed in the background if the sky is enabled, and the HDR image will be displayed if the sun and sky are turned off. You also have the option to set it to a single color, or a custom image or spherical image. For this training, let us leave it at environment background. In the VR tab, you will have several options that affect the VR experience. The first option is to enable the night mode. Enabling night mode will override the HDR and sun settings and display a night sky with a matching light environment in the VR experience. Next is the fog option. With the fog option, you add a volumetric effect to the VR experience, mimicking the appearance of fog, where you can control the fog's color, density, and starting distance. This option is suitable for large scenes and especially exterior scenes, since it adds more depth and a better sense of distance. The auto adjust brightness option would prevent the sky and HDR to have an overexposure value in the VR experience to avoid a scene where the objects are overwhelmingly bright. Under navigation, you can set the default mode of desktop navigation, which can then later be changed during the VR experience, as well as the player camera's field of view. The default value of 65 is good, so let us leave it at that. The last option under navigation mode is to enable VR flying, which, as the name suggests, enables the user while running the experience using a VR headset to fly in the scene using the thumbstick on the left controller, and when that option is enabled, you can choose whether to allow the user to penetrate objects and walls by enabling or disabling the flying collision option. Under Scene Settings, you have the option to export light maps with the VR experience when available, as well as control the shadow quality and the density of corner shading, which is similar to the ambient occlusion effect. You can additionally control the measurement units when using the measuring tool that is built in within the VR viewer when running the VR experience, and also control the scale of message boxes in a VR experience. Enable Highlight is the default option where interactive and grabbable objects will be highlighted during the VR experience. When this option is disabled, objects in the scene will not have any indicator that they can be interacted with, which is suitable for training and educational VR experiences where you want the user to be completely immersed and not have any hints on what to do during the VR experience. The last option in the VR tab is the Catalog option. Including a catalog in the VR experience enables the user to import the catalog's 3D assets online during the VR experience. It is usually used in visualization and demonstration-based VR experiences, where the user wants to browse a collection of products or items and import them to examine them. Now that we are familiar with the basic settings of VR, let's go ahead and try to run this scene in VR. The first step in running the scene in VR is to set the starting position. From the VR viewer menu, select Set Start Position. A humanoid character will be imported to the scene. This character will determine the user's initial position in the VR experience or where he would start, so let's set it in front of the panel. Click the Snap to Object icon or press in on the keyboard, then click on the platform in front of the panel to snap the character there. Now rotate the start position 90 degrees to face the panel. It seems that the panel is slightly off the ground since we have been transforming it earlier, so let's try and reset its position. Click on a component in the panel, then click the up arrow until you reach the assembly named panel. Then press G on the keyboard to snap the panel to the grid, which coincides to be on the same level as the platform. Let us also scale it down slightly, and then again press G to snap it on the grid. Use the arrows to fine-tune its position, and once you're happy with it, go to the SimLab VR Viewer menu and select Show in Viewer. A window will appear asking you to select a mode to run the VR experience in. If you have a VR headset attached to the PC like HTC Vive or Oculus Rift, then you can select PC VR. If you have a standalone VR headset like Oculus Quest or Pico, or a mobile phone or tablet, then choose Standalone VR. If you want to run the VR experience in desktop mode, then choose Desktop mode. I will go with Desktop mode for the training. Once the geometry is exported, SimLab VR Viewer will run the scene as a VR experience. The basic navigation in desktop mode is to use the WASD keys or the arrows to move around in the scene, and to use the mouse to look around. You can press F2 on the keyboard to toggle the full screen mode. Now that we have run the experience for the first time, let us now move to the second part and create some interactions for the panel in front of us.